you are collecting the data of 10 peoples, something a food, everyone has tasted a food, and you told somebody told not good, somebody called medium, somebody told good. So it has been taken a data as a good, not good, and medium. We call it as a data. Yes, it is a data, but it is a different type of data. Okay, so data is something else, which is, it may be in the form of a text, maybe good or not good. It may be in the form of numerical number, maybe 1, 2, 3, 4, 5, 6. It may be something like 0 and 1, probability concept. So you will have either 0 or 1, 0.8 or 0.9, right? That is also kind of a data. So statistics it is a mathematical technique, or the techniques to analyze the data, different types of data. Okay, and so that's what the data means. What it is, something like, which is something, anything which is related to text or a fact or maybe a number is called it data, right? So for example, there are two types of data you will get. One is called as variable data and attribute data. Have you heard about these words? Variable data and attribute data? You are aware, but you are not able to recall. You know already, but you are not able to recall. What is variable data? Variable data is nothing but it is a continuous data, where it is number in form. Okay, the time is a variable data, right? And attribute data means it is in a text form, where you are telling that they are good or not good. Okay, so this kind of data is called as attribute data. Say for example, variable data means like maybe voltage. Voltage is a variable data. Why voltage is variable data? Because you are measuring the volt. Okay, the voltage is a variable data. And the power, the weight of a human being is a variable data. Weight will not come as a medium and low. Weight will come as a 4 kg, 5 kg, 10 kg, 20 kg, like that. So whichever the data which comes in the form of numerical way, it is called as a continuous data, right? Then and these data will be measured by using instrument. Voltage will be measured by which instrument? Voltmeter or ammeter? Voltmeter, very good. That means you are all electrical engineers, I think. You are very efficient enough to give this answer. So current will be measured by ammeter. So that means ammeter you are measuring in terms of numerical value. Whatever the instrument is giving is numerical value, no? So that kind of data is called as variable data. Okay, let's talk about the attribute data. What is attribute data? Attribute data means it is a number. You are counting the numbers. How many number of people are high score numbers? That means first class passed. How many numbers are passed in second class? How many students are passed in third class or in below average kind of thing. So when you are counting the number recording, that kind of data is called as attribute data. So if out of 100, 20 people are maybe outstanding, that means you are grouping. So first class students, second class students, and the below average students. That kind of data we call as a attribute data. For example, surface defects, surface variation. Okay, so these are all type of data is called as, you are just classifying into different groups. Okay, so that kind of data is called as attribute data. So attribute data also having two types. So binary data. Binary data means what? It is just only having two options, right? Number of defects, number of students passed in only first class. Those kind of the counting data is called as binary data. It have only the binary data, means into two groups only, and it may be calculated as a proportion or percentage wise we'll tell. So approximately 20% of the 100 students have got first class. We'll not tell 20, we'll tell 20% of the 100 students got a first class. That is a proportion you are calculating or percentage you are calculating. Those kind of data are called as a binary data. Some data are countable data. Count data are there. It may be in the form of 0 or 1, right? That means number of occurrences of the characteristics in a group of items. Some group of item is there where you are counting it. How many number of times the defect product came. Such kind of data collection is called as count data. So different type of data, different type of analysis need to be do. Because in additive manufacturing also we come across various types of data. Maybe some are product quality is the one data, maybe some are process time is the one data, maybe some other data which is having related to maybe variable or attribute data. Now you tell me what is variable data? What is variable data? Pardon? Variable data are those data which are measured by instrument, right? It's called as variable data, which is in a numerical form. What about attribute data? Which is not in numerical form, it is in a text form or group wise, is called as attribute data, right? Something like number of defects in a particular batch, number of accident happens in a city during June 2005. So how we will record this type of data? We will say that around 20 accidents happened in July 2005. Around 20 accidents kind of. We are counting only. We are not measuring, right? We are counting. If you are collecting the data in terms of counting, we call it as a attribute data. Or it is sometimes it is called as a count data. We are counting the things and recording it. So like accidents, right? Accident we are not measuring how much damage happened and all, we are not measuring. We are saying that on an average in July month around 20 accident happens in the Visakhapatnam. Like that we measure or we will collect. Such kind of data we call as a count data. Okay. So then if you talk about the statistics, there are two types of statistics are available. Okay, when you classify the statistics, one is called descriptive statistics, another is the inference statistics. Descriptive statistics you might have studied in M2, mathematics 2, right? And inference statistics you might have studied in M3 or maybe M2, mathematics 2 or mathematics 3. So since you know aware, I think descriptive statistics and inference statistics, so I want to know from you first, descriptive statistics and inference statistics. So descriptive statistics means you have a data and you want to see how the trend of the data, means stock market, right? You want to see in stock market graph is always increasing or decreasing, right? It is kind of data and it is having some trend. You want to see only the trend or you want to see only the data how it is there, how the data pattern, that will be done by descriptive statistics. And after plotting the data and you want to conclude in the next month maybe share market will be approximately 90% will grow. So the decision will take after the analysis of the data, we call it inference statistics. That means statistics means analyzing the data. Data is the two types, continuous data and attribute data. Again in that statistics, one is a descriptive statistics and inferential statistics. Descriptive means here you are plotting the data, analyzing the data and observing the data trend, how the trend is going on, how many accidents happens, what is the probability that and how the, whether it is a decreasing trend or whether increasing trend or whether it is equally happening in a particular month or particular like that. That kind of study we do in a descriptive statistics. But inferential means you have done that analysis. Further, what will be the prediction? So how many accidents may happen in future in the next month of October in the Visakhapatnam? That prediction will be done in inferential statistics. So in both the statistics, we use different types of techniques. So have you heard about histogram? Have you heard about box plot, interval plot, scatter diagram? All are descriptive statistics. Have you heard about regression analysis, ANOVA, T-proportion test, test of hypothesis? These are all comes under the inferential statistics. So what are the different types of statistical methods? Here are the statistical methods for different. One is called as descriptive statistics. We use these types of methods. Inferential statistics, we use central limit theorem. So this you study in M2. mathematics 2, central limit theorem, right? And then binomial theorem. Binomial theorem you might have studied, right? It's a binomial distribution. What is the speciality of binomial distribution? Sir, we have studied and we forgotten. So these are all M1, M2 only, right? Binomial distribution. Then normal distribution. You might have heard normal distribution. So this is also kind of inferential statistics, where whether our data is following the normal distribution or not. And some of the t-test and ANOVA test are the different analysis we use for our inferential statistics. So to analyze the variance, okay. So and other techniques also are available. So one can use this technique for your analysis. So now the questions comes when we have to use this descriptive and what is called inferential statistics. So when you have a excess means what? Maybe your input variables. Y is nothing but your output variable. If your output variable and input variables are continuous and continuous, that means your output variable is maybe product quality, output variable may be process time, output variable may be machining time, output variable may be anything, right? Output. If your output is in continuous means numerical data, text, not text data, numerical numbers. If it is in number form, then your XSR means input conditions are continuous. Which particular statistic tool will be used is a scatter plot. In Excel also it is available, scatter plot. Have you seen? You might have worked on X and Y column, you have plotted, but you don't aware about that particular concept. That means X is also in the number form, Y is also in number form, then we use scatter plot. When Y is a continuous, but it is a discrete. Discrete means text format. Means your X's are text format, Y's are in a continuous format. Then in that case we use box plot. Alright? It is available in almost all the Excel sheets. Box plot is available. Okay, then if reverse case, if Y is discrete and X is continuous, that means Y is good or bad. Food of the taste, good or bad. Y is a discrete. X is number of restaurants. X is a number of restaurant, right? 5 number of restaurant. And Y is your discrete. Good or bad. Taste is a good or bad. Taste is your Y. X is a number of restaurant names. So then how will you analyze? You will analyze by using a box and interval plot. If both are discrete, that means X is also in the text form, Y is also in text form. In that case, we have to go for stacked bar graph. All are available in our Excel sheet, but they are not aware about that. Okay, so now these are graphical techniques. Analytical technique also we use in descriptive as well as this. So if Y is continuous and continuous, we use correlation regression. Suppose you have a input condition as a layer thickness, you have an input condition as maybe something else, height or temperature, and Y you are measuring as a process time, something else. In your electrical systems, what are the inputs? Tell me, in electrical system, what are the inputs? Current and the voltage, and output what you measure? Power and resistance, right? Power you measure, and the resistance is also you calculate, right? Now your power is a continuous format, continuous data, and input is also continuous data. Then if you want to use graphical techniques, what you will use? Scatter plot. So in analytical technique, what you will use? You will use the correlation and regression. Okay, regression you might have heard. Regression means it is something like a tool for prediction purpose. So I want to predict the today's share to tomorrow. What will be the tomorrow share? You want to predict, then you have to use the regression technique. In additive manufacturing also, we can predict easily the process time or the quality of the output characteristics. If the Y is discrete and X is continuous, then logistic regression we use. That means we have the Y is in discrete means text format. Y is in text format, but in X is continuous format. In that case, we have to use for logistic regression. And If y is continuous and x is discrete means t-test you have to use. T-test, have you heard? Test of hypothesis, other t-test we call as. So when we use t-test, suppose your bank manager told that our ATM machine will dispatch the cash within 5 minutes. You agree? You agree or not? Bank manager told that our machine is very capable enough, it will withdraw the cash within 5 minutes. You will agree? Or you want to test it, whether it is correct, he is telling correct or not? Right? You will test, right? Because it will not be same. Exactly, it will not be same as 5 minutes or 5 seconds, rather I would say. So you need to test it. Our manager, whatever the statement he has told, ATM machine is withdrawing within 2 minutes or 5 minutes. You need to check it, whether the statement is correct or not. To check that statement, we go for hypothesis testing. That means whenever a particular person is commenting on you, that means you have to check whether that correct or not, right? If somebody commented on you and you are liking or you are taking a granted way, that is not correct, right? You have to check that particular statement given by your friend or maybe someone on you, whether it is correct or not. That testing will be done using a hypothesis. Okay? So hypothesis nothing but somebody has commented you and you want to test that comment given by other person is correct or not. That comment is checked by a hypothesis test. Right? So that is what it is, a t-test we call as. Sometimes we call as a ANOVA also, analysis of variance. Let's have a demonstration, one case study will take. So how this statistics will help in a particular case study. Okay, additive manufacturing case study will take. So here our case study will be tensile property. Tensile property I want to study. Tensile property means it is my output, y value, right? That is what y value. I want to measure the y value for a particular polymer material using some Taguchi method. What have you heard about Taguchi? No. So it is a statistician. He is a statistician. He developed the method called as Taguchi method. You will use in your MTech and all. So here my output is what? Tensile. Tensile means y. Y I am taking as a output. Some to get y, I need some input, no? So your input is a material. Material may be different types of materials I am using. There are two types of input I am taking. Okay. So here there are two types of input I am taking. One is infill density, another is what is called as material. Now you tell me, infill density is a continuous data? Infill density, something a density is there which is in a percentage form, 25%, 75%, 100%. It's a continuous data? This number, no, it is a continuous data. Whereas material, PLA material, ABS material and bio-ABS material is a categorical data. Right? Understood now what I am trying to say? So there are two input conditions I am taking. One is infill density, another one is called as material. Infill density is in some percentage. Percentage means it is definitely a what data? It is a continuous data I can take, right? And then material is text data, right? It is having a text data. And my output is strength. Strength is a continuous data. If you see here, so different infill density I vary, different material I am varying, I am getting the different tensile strength. Now I have a data. For which data it is a additive manufacturing data. Some additive manufacturing system is used and develop this data. So that means this model has been developed and by using machine and we got a data. 9 data we got. Right? Is a data now? We call this as a data or not? This is a data. And when you have a data means what you need to do? You have to go for statistics. You have to analyze the data. How the trend of the tensile strength, how the trend is behaving, whether it is increasing trend or decreasing trend, or it is having its mean 0 or not. Standard deviation how much? What is mean by standard deviation? What is mean? Mean is nothing but average. Suppose I have 9 data. So how I could calculate the mean? Summation of all xi's by number of values. So okay, so that means summation of xi, summation of I is equal to 1 to n, xi upon n. That is the mean formula, right? What is mode? You have a 9 number of data. What is mode? In Excel, just mode option is there. You will calculate, sir. We don't know about the theoretical aspect. Huh? Number of? There are 3 terms are there: mean, median, and mode. Right? These are the 3 important descriptive statistics methods: mean, median, and the mode. Mean is nothing but average. Mode is nothing but. First, median we will discuss. What is median? Middle element of the data. Suppose I have a data of okay. So this is something a data is there. I want to find out the median. Can you tell me which one is the median? 3. That means when you divide this number, 3 are in the above and 3 are in the below. It is called as a median. So did I did correct? Or first I need to arrange in the ascending order? We need to arrange as a ascending order. Whenever you are calculating the median, you have to first make your data into ascending order. Then C is the middle value. Then from the middle value should be equally distributed. It is called as a median. Let us assume that I have done it and I got 3 as a median value. Okay. Another value I am adding here. Then what will be the median? What will be the median? Median will be, assuming that I have done the ascending order, and definitely these 2 divided by 2. Right? Will be your median value. Then what will be mode? The element or number which is frequently occurring in the data set is called as a mode. So here it is any value is frequently occurring. None of the 2 is the mode here, right? Here two number is occurring 2 times, right? So the mode of this series is 2. So if there is suppose 2 values are in occurring several times or equal times, here in this 2 times is got. Again if I add one more, 3 here, so 3 also is occurring 2 times. Then two modes of this series, M1, M2, भूल गया क्या? Everyone is forgotten. M1 and M2 only. So if 2 numbers are frequently getting, both is having a modes, means this series is having a 2 modes, right? It is having a 2 modes. So since 2 numbers are getting, so that's why it is called the 2 modes. So every data set having maybe more than 2 modes also. Okay. So that is why here also I want to, since it is the data, I want to calculate the what is the trend of this particular data. Okay. In a statistician language I say as a data. Here okay. So this is my data and I want to study this data, that how the my strength will be good for this particular process. So this type of data will be studied. This is a graphs you are seeing, no? So is it a descriptive statistics or inferential statistics? Just 5 minutes back only I told. Descriptive statistics is that statistics where you are analyzing the trend of the data. Since I am analyzing the trend here, right? I am analyzing the trend how my input values are varying with the output value. I am only trend. I am seeing the trend, whether it is increasing trend or whether it is decreasing trend. I am just observing the trend is what is a descriptive statistics. This is a descriptive statistics. Data I got from the process, and then from the process, and I plotted the graph. Something a technical word is the mean effect plot we tell. So since you are not much in research side, so that's why I'm in a layman language I'm telling that this is something graph which describes some behavior of the input with respect to output. Here my output will be your strength of a particular object, and input will be, there are two inputs. One is infill density, other is the material. Okay, so that means, so now can anybody tell me what is the behavior here showing by seeing the graph? Strength will be behave with the input is linearly or non-linearly. So with respect to first input of input and infill density, my strength will be varying. Up to certain level it is linearly, and after that it is decreasing. So that means I can interpret that there is a level change when I am changing from 25% to 75%, my strength of the component is increasing, like linear behavior is showing. Whereas after 75 it is getting decreasing, slight decrement is happening. Maybe due to some technical language, I don't want to tell that. Okay? If I tell also you will not understand. So there may be something happens due to which there is a slight decrement in the strength is happening. What about material? When I am changing the different types of material, is a linear interaction, linear behavior, right? No, because when I am changing the material, what happening? The strength will be increasing, right? The trend will be increasing mode. So when I am changing this particular A material, B material, C material, then the trend is increasing. It's called as linear behavior. So this is a descriptive statistics. And even this is a something like that, something interaction plot. So what is interaction? Interaction means when two elements are coming together, and then it is called as interactions. Okay. So if I draw these two elements like this, something A element is there and B element is there. See, we say interaction, right? Something like if I draw this way, if A is there and B is there, A line and B line, can I say interaction? Why? Okay, another graph I draw. So there is another graph like this. This is A line and B line. When I say interaction, so in all the three cases, which one is interaction? This one, according to you, this is interaction. This is not interaction. This is interaction, and this is not interaction. Good. So when two elements are crossed together, we call it a strong interaction. It is having some strong interaction between A and B. It is a moderate interaction. It is going to interact with here. At certain period of time, it is going to interact. This is also interaction, but it is a moderate interaction. It is a strong interaction. When both the lines are parallel enough, then we say that no interaction. Okay, for example, if I will give you another example. In railway station, you might have seen coolies are there, right? They will. What is their objective? If I formulate as an objective function, as a mathematical formulation, if I do what a coolie person, I want to optimize the coolie person, right? How I will optimize? His objective function is lifting of the weight. How much capacity of the load he will lift, right? So, for example, coolie number A lift as 100 kg. His capacity is 100 kg. Objective function is 100 kg, right? Coolie number B is having 80 kg capacity. Now they are very good friends. They want to club together. They want to work. Okay. What is a club together interaction? How much kg they can lift? One person is 100. One person is 100. Another person is 80. So if they are very good friends and they want to club together, and how much interactions after clubbing A and B, how much they can carry? 180. It is simple mathematics. 90? Anybody? Anybody?